Hi, this is Lynn Turback, and welcome to the third in a sequence of screencasts covering the second half of the Objects from Scratch slides that would have been covered in the Friday, April 19, 2013 lecture had it not been canceled. In the previous two screencasts, we looked at the Buggles from Scratch example, where we studied how to declare instance variables, constructor methods, and instance methods for a simple Buggle class. In this screencast, we're going to cover a second kind of variable declaration that can be in a class, which is a class variable. And we will see how we can make an extension to simple Buggles that exhibit this use of class variables. And the example that we're going to show is extremely relevant to your problem set 9, task 1 text turtle problem. Okay, so what is a class variable? A class variable, also known as a static variable, is something that belongs to the entire class, not to any particular instance. In other programming languages, these variables are called global variables. They're variables that any entity in the program can refer to. In Java, there is no notion of global variables. The closest thing we have are these things called class variables. And class variables live in a new kind of land that we haven't discussed before, which is class land. And you've seen class variables before. So for instance, when you say color.red or color.cyan, you are referring to variables that live in the color class. These are not things that live in a color instance object. Rather, they live in the color class. And so in this diagram that we see here on the left, we have class land showing the color class, which in this case has two class variables called red and cyan. And the contents of those variables are instances of the color class which live in object land, which is different than class land. Okay, so how would we actually declare class variables? It turns out if we opened up the color class, we would find that it contained declarations something like this. It has these so-called static variables. That's how we declare class variables. So if we want something to live in class land, we declare that the variable is static, and that means that red and cyan will now live in class land. And we have initialized them to be instances of the color class shown here. We have also used the keyword final. The keyword final, as we mentioned before, indicates something that can be assigned once, but to initialize it, but can never be changed thereafter. So these variables, in this case, are effectively immutable, which is good because we don't want someone to be able to change what color.red means after we have defined it. Now let's consider an example that's going to require the use of class variables. Suppose we want to make an extension or a subclass of Buggles called a serial Buggle. And the only difference between a serial Buggle and a regular Buggle is that a serial Buggle has a unique ID, and that ID for the first Buggle is 1, for the second Buggle is 2, and so on. So they are allocated in sequence, which is why we use the name serial Buggle. So for instance, here consider an example. Suppose we create 3 serial Buggles, the first name Sally, the second name Sam, and the third name Sarah. Then Sally's ID will be 1, Sam's ID will be 2 because he was created second, and Sarah's ID will be 3. So this allows us to distinguish the Buggles, serial Buggles, based on the order in which they were created. Again, each one has a unique ID. And we'll assume that this ID, new ID instance variable for serial Buggles is public, so in fact anyone can access it. Okay, let's see how we would define the serial Buggle class to implement this behavior. First, we're going to define a class serial Buggle by extending the existing Buggle class. That is, serial Buggle is going to be a subclass of Buggles. And the serial Buggle class is going to need a place to store the next ID that we are going to allocate. And so we're going to use a class variable for this purpose. So we are going to have a variable named nextID, and we declare it static because we want this to exist in class land, it's effectively a global variable that we can use when creating any of our serial Buggles. And we're going to initialize this to 1 because we want our first ID to be 1. But this next ID variable will change over time, and it will always have a value which will be the number to be allocated to the next serial Buggle we'll create. We also want each Buggle now to have an instance variable. We will name that instance variable ID. As I said before, we will make it public so anyone can access it. And we will also declare that it's final. This means that once we specify the ID of a serial Buggle, although others can access it by saying .id, they will not be able to change it by saying .id gets. So this makes the instance variable effectively immutable. And now let's take a look at the constructor method for serial Buggles. So all we need to do when specifying a constructor method for a subclass of Buggle is what's different than the default constructor method for Buggles. So here all we need to do is talk about how we're going to manipulate the ID, all the stuff with positions and directions and colors and brush down, that will be handled automatically. So here is the entire definition of our serial Buggle constructor. We're going to do two things. In the first part, we're going to set or initialize the ID of our new serial Buggle to be what's in the next ID class variable. And then we are going to increment the next ID class variable so that it has the correct number for the next serial Buggle that we are going to create. Let's take a look in the Java execution model to see how this works. Suppose we go off and make a call to a constructor method, make a new serial Buggle. When we do that, a lot happens right away. We will create in object land a serial Buggle, let's call it SB4, that has the usual default position, direction, color, and brush down variables. And it will have a new ID variable that, because it's an integer, will have the initial value 0 because that's the default value for integers. And our execution frame will have a variable named this that holds on to SB4. Okay, so now we go off and execute the first statement in the body of the constructor method. We find that this is SB4. And we now look at serialBuggle.nextID. That gets the class variable out of the serial Buggle class. And we find that that value is currently 4. And so now we change the ID value in SB4 from 0 to 4. So now the serial Buggle SB4 knows that its ID is 4. And in the second statement of the constructor method, we go off and change the next ID in class variable in the serial Buggle class to be 1 more than its current value. So now it will be 5. So the next time we go off and create a serial Buggle, it will be given the ID of 5. Okay, one more thing we have to note is that just like there's an abbreviation for instance variables where we can just use the instance variable rather than using this dot, the instance variable, there's also an abbreviation for class variables where we can get rid of the class variable dot in front of the class variable, so that we could in fact rewrite our serial Buggle constructor to look like this instead. So we can get rid of all of the dots. And Java is smart enough to figure out which things are instance variables, i.e. which things should be this.id, and which things are class variables, i.e. which things should be serialBuggle.nextID. And it knows how to do that. So we could have written our constructor method this way. We'll conclude this screencast by summarizing the 5 different kinds of declarations that may appear in a Java class declaration. So there are 2 different kinds of variable declarations we can have. You can declare an instance variable, and an instance variable is any variable declaration, not inside some method, but just alone by itself inside the class declaration, that does not have the keyword static. For instance, if we say public int x, We are saying that our object should have an instance variable named x that's an integer, and we know it's an instance variable rather than a class variable because it doesn't have the keyword static. Class variables are also variable declarations. They are distinguished by having the keyword static. So if we say public static color red, it means that inside of our class we are declaring that it should have a class variable named red, and that red class variable should contain a color. There are three kinds of method declarations that we can have inside of a class. You're very familiar with instance methods. So these are methods. And we know things are methods because they have parentheses. Variable declarations do not have parentheses, but method declarations do. So because we see parentheses here, we know it's a method declaration, and we know it's an instance method because it has a name of a method, it has a return type or void, and it does not have the keyword static. So that makes an instance method. And we know how to invoke instance methods. To invoke an instance method, you take some expression that denotes an instance, like Bob here might be a Buggle, and we use the dot notation, dot forward, supplying our parameters to invoke an instance method. Class methods are similar to instance methods, except they are denoted by having the keyword static. Like instance methods, they have a name and a return type and parameters. And the difference in invoking an class method from an instance method is that when we invoke a class method, we also use dot notation, but the thing to the left of the dot is the name of a class as opposed to being an expression that denotes an instance of the class. So here, intlist.head is a class method that we are invoking from the intlist class. And the third kind of method that we can declare inside of a class is a constructor method. Constructor methods are special. They have a name that is the name of the class, and that name serves as both the name of the constructor method and the return type, so those two are not separate. That's how we know this is the declaration of a constructor method. And constructor methods are invoked in a special way. We invoke constructor methods by using the keyword new, followed by the name of the class, which is the name of the constructor method, and any parameters. So those are exactly the 5 different kinds of declarations we can have in a Java class, and those are it. There's no more. There's nothing we're not telling you here. There are exactly 5 different kinds of class declarations you can have inside of a Java class, and these are the 5. So you should be able to take a look at any Java class in the future, and then based on these syntactic hints, determine which of the 5 different kinds of declarations. Again, 2 kinds of variable declarations, 3 kinds of method declarations.